Hello, students. Today and for the rest of your time here, we're going to be talking about theoretical probability. Theoretical probability is the mathematical likelihood of a certain event happening. The way we calculate it is we do the number of desired possibilities or desired outcomes over the total number of possibilities. So the number of desired outcomes over the total number of possibilities, and that is how you calculate a probability. And generally they use P to indicate probability. So that's why here at the bottom we have probability of even, probability of prime, probability of 9. So P of even, P of prime, P of 9. And that's how we calculate the probability. Now probabilities range from any value 0 to 1. So the likelihood of, let's say, Jay-Z showing up at the school, that's probably a 0. The likelihood of Dr. Davis showing up at the school, that's going to be a 1. He is very good attendance, or very close to 1. So these probabilities range from a minimum of 0 to a maximum of 1. There are several different ways to show probabilities. You can show them using words, so 1 chance in 8. You can show them as a fraction, 1/8. You can show them as a percent. That's where you divide the two numbers, multiply that by 100, or show them as a decimal, and you get that decimal just by dividing the two numbers, 1 divided by 8. At this point, generally you're going to see that as a fraction or as a decimal. The higher on, like if you took a probability class in college, they'd probably show them mostly as decimals. So this particular problem gets at if we have an octagonal spinner, so 8-sided shape, written looking like a spinner here, and we want to know the following probabilities. So P of even, so probability that you get an even number. If we look at this spinner, we have evens at the space 2, 4, 6, and 8. So the number of desired outcomes, we have 4 evens over a total number of outcomes, 8. So the probability of an even is 1/2, or 50%, or 0.5, or 4 chances in 8. So that's our probability of even. If we wanted to know our probability of prime, so the probability we had a prime number, we would identify our prime values. So to identify our primes, we have to consider the numbers divisible, only divisible by itself in 1. So 1 is not considered a prime number. You know, that's a little tricky. But our lowest prime number is 2. 2 is prime. 3 is prime. Is 4 prime? Nope. 5 is prime. 7 is prime. So those are our prime numbers. We know 8 is not prime because it's 2 times 4. So of our primes, the number of desired outcomes or primes are 1, 2, 3, 4. So for this, it's also 4 out of 8. So we have 1/2. So again, 50% chance on this spinner of getting a prime number. And then if we look at the probability of getting a 9, our probability of getting a 9 is going to be 0 because you can't spin a 9 if our highest number is 8. So we can see that all of our outcomes do range between 0 and 1, 1 being our highest probability, 0 being our lowest probability. And here we have, you know, everything is within that range of numbers. And again, these are mathematical probabilities. If I were to spin 100 times, would I necessarily get 50 even spins? Probably not. It probably wouldn't be 50 exactly. So that would get to an experimental probability. Experimentally, what exactly would happen? But mathematically speaking, or theoretically, I should get 50. So that's the difference between a theoretical probability and an experimental probability or outcome. Okay, so in general, for an event A containing equally likely possible results, this is our formula, which I outlined before. We have the number of members of the event A over the total number of possible outcomes, and that's denoted by n of A. So in that case, like the number of primes over the number of outcomes. So the number in U, and U is just kind of the universal set. That's what they're using the U for. So that's like all of the different outcomes. And N is just used as the number of. So that's that formula. So let's take a look at this example. It says a ticket is randomly selected. That's very important because if it's not random, these will all be different. From a basket containing 3 green, 4 yellow, and 5 blue tickets. Determine the probability of getting a green. So we know our desired outcome is green. So there are 3 green out of a total of, and we'll add up, we have 7 plus 5, so we have 12 tickets. So it's 3/12. If we want to reduce, that's 1/4, or a probability of 0.25. Then we have a probability of a green or yellow ticket. So we'll be happy if we get a green or a yellow. So what we'd have to do is sum up green and yellow. So green and yellow, that is a 7 out of 12 probability. No need to reduce there. So probability of getting a green or a yellow is 7 out of 12. Probability of an orange ticket, well, since we have no orange tickets, that's a probability of 0. And then probability of a green, yellow, or blue. What is that one going to be? Yep, it's 100%, because all of them are either green, yellow, or blue, or we could add them up. It is 12 out of 12. So you could say it's a probability of 1. You could write it that way. You could write it as 100%. It's up to you. So that's the gist of a very basic probability problem. Now, one way to consider probability if there's a lot more possibilities than this is considering what is called the complement. So the complement we're going to talk about when we talk about B and D. So let's take a look at rolling 1 die. So die is just the singular of dice. So an ordinary, and they're saying ordinary because it is not like a loaded dice or a weighted die. It's just you have an equally likelihood of getting a 1, 2, 3, 4, 5, or 6. So the probability of getting a 6 is just 1 out of 6. Because you have 6 sides on a cube, and on that cube you have all the numbers 1 through 6. So the probability of getting a 6 is 1 out of 6. Now for B, the probability of not getting a 6 is the probability of getting a 1, a 2, a 3, a 4, a 5. So it's the same as the probability as 1 minus 1/6. So that's called using the complement. So it is 1 minus 1/6. This is all possibilities minus the undesirable outcome. So all possibilities. I don't know why I put a little hyphen in there. So let me get rid of this. So all possibilities, or all outcomes, would be 1 minus the undesirable. And so undesirable, getting a 6, is 1/6. So that's going to be 5/6. So the probability of not getting a 6 is 5/6. And that's going to be easier than saying, oh, how many desirables are there? So 1, 2, 3, 4, 5, we can just do the complement. So that's called using the complement. Probability of getting a 1 or a 2, 2 out of 6, or 1/3. Probability of not getting a 1 or a 2. So we already calculated the probability of getting a 1 or a 2. So the probability of not getting a 1 or a 2 is all outcomes. So probability of getting all of them is 1. 1, 2, 3, 4, 5, or 6 is 1, minus the undesirable outcome, the 1 or the 2, is 1/3. So the probability of not getting a 1 or 2 is 2/3. So that's called using the complement. And complement is spelled a little differently. This is the mathematical version of complement. So it's basically saying like everything but. It's the complement. Like complementary colors, kind of like that, like yellow and blue and red and green. So it's mathematically the complement there. So not getting a 1 or 2, it's 1 minus, because you're doing everything but that. So that's using the complement, and it tends to be a little faster if there are a bunch of outcomes. And here we go. If two events are complementary, so take a look at that spelling. If exactly one of the events must occur. So if A is an event, then A prime is the complementary event of A, or not A. So the probability of A plus the probability of not A equals 1. And so like getting a 1 or 2 plus the probability of not getting a 1 or a 2 is 1. Probability of school being on plus the probability of school being canceled is 1. So those are complementary events. Okay, so here is your homework 15C1. So this assignment will be given to you, and you will have the rest of the period to work on it. Good luck.